Hi there, welcome to my YouTube channel. In this video, we will be discussing the air conditioning processes. So part 1, sensible cooling and sensible heating. So first, the sensible cooling. The basic function of air conditioners is to cool the air absorbed from the room or at the atmosphere, where it is at a higher temperatures. The sensible cooling of air is the process in which only the sensible heat of the air is removed so as to reduce its temperature, and there is no change in the moisture content in kilogram H2O per kilogram dry air. So since we will not be using the upper side, the upper left side, which is the protractor, I'll be covering this. So for instance, we have a system. Okay, we draw that. Okay. This is point 1. This is point 2. And a stream of air which has a mass 1 and properties like dry bulb temperature, humidity ratio 1, relative humidity, and so on. Okay, enters a system, and let's denote the initial. Okay, let's mark the psychrometric chart as 1 in this psychrometric chart in this portion. Then we have a cooling coil within the system. The air encounters the cooling coil and the heat is thrown out, but only to the extent that only QS, or the sensible heat, has been removed, okay, such that as it exits at point 2, the mass air 2 is just equals to mass air 1, since we have a conservation of mass. But the temperature dry bulb 2 is lesser than temperature dry bulb 1, since we are cooling. But the humidity ratio 2 is equals to the humidity ratio 1, since as we defined earlier, there is no change in the moisture content, and a relative humidity, okay, 2, this one 1, which is much lesser than the relative humidity 1. So as we plot it in the graph, the psychrometric chart, there it is, okay, in this direction, since we are cooling. So for example, we have the point, we reach the point 2, and we register all the temperatures. The dry bulb temperature, dry bulb 1, temperature dry bulb 2, but the humidity ratio W2 is equals to W1. But the relative humidity, as we can see it, is as it goes to the left direction, it increases. Furthermore, the enthalpy has been reduced, since we are making it cooler than the initial state. So this is the enthalpy part. Okay, we can also see that in the upper left portion. It's the same, it was plotted straight. Okay, and we must take note that heat total is just equal to QS, or sensible heat, plus latent heat. Okay, sorry, I'll make this one clear. Okay, that. So since there is no change in humidity ratio because QL is associated with delta W times 2501 plus 1.86 dry bulb temperature, and okay, any number multiplied by 0 because our delta W is 0 because there is no change in delta W. Any number multiplied by 0 is equals to 0. So we have only Q total is equals to QS, where QS has been defined as CP delta T. And the delta T is the difference between these two dry bulb temperatures. And now we proceed to the sensible heating. Sensible heating process is opposite of the sensible cooling process. In sensible heating process, the temperature of air is increased without changing its moisture. During this process, the sensible heat, the dry bulb temperature, and the wet bulb temperature of the air increases, while the latent heat of air and the dew point temperature of the air remains constant. So again, we make a system, and this time it is heating. Okay. That one, we have boundary 1. And this is the heating coil. This is boundary 2. So a mass of air 1 enters the system with having a temperature dry bulb 1, humidity ratio 1, relative humidity 1, enthalpy 1, specific volume 1. Okay? So we plot it here, somewhere here. The temperature is much colder, like that. So we have the relative humidity, the temperature dry bulb. Okay? Dry bulb 1, while the humidity ratio is this one. Okay. As it enters the system, it is being heated by the cooling coil, where the QS has been supplied, and whereby only the dry bulb temperature has been increased. So after some time, it goes out in the system, which has the same mass A2, which is equals to mass A1. Since we don't have any leakage or any entries of air, so the mass remains constant, while the dry bulb temperature 2, okay, for example, this one at this point has been increased, which is greater than temperature dry bulb 1, and the humidity ratio 2 will remain the same since we're talking about sensible heating only. Okay. Also, we take note that the relative humidity 2, okay, has reduced. Okay, from, for example, this is the relative humidity 1. So it has reduced, okay, from somewhere 50, 30, I mean 30. It has reduced to, I think, 8% or 7%. Okay, 7%, like that. And we take note that the dry bulb temperatures, the dry bulb temperature of the air has increased, and this is your enthalpy. That, so this is H1 and this is H2, where the difference of that, okay, Q total is equals to QS plus QL. Again, associated in the QL is the change in humidity ratio, so there's no change in humidity ratio, therefore it's just equal to QS, where QS is, okay, H2 minus H1. So I hope this helps a lot in your learning, and see you in my next video.